Hello everyone, welcome back. Today we are going to talk about ECU. What is ECU and what does it do? The engine control unit, ECU, is a microcontroller-based computer that sends control commands to the actuator based on information received from sensors. Yeah, it's all about sensors actually. And the ECU is responsible for optimally adjusting the air-fuel ratio, managing the ignition timing of spark plugs, controlling the operation of the cooling system, and in more modern vehicles, even handling functions related to the transmission and safety systems, okay? And you can see internal structure of ECU here. ECU is made up of several different sections: inputs, memories, outputs, and outputs include commands sent to the injectors, ignition core, radiator fan, fuel pump, and other actuators. Yeah. Okay, it's all about sensors, as I said. Electronic engine management is all about getting accurate information from the engine's environment and then sending out accurate signals to the control mechanisms of engine. In a typical system, we have throttle position of the actuator, accelerator. These are input sensors, okay? Air temperature in the intake manifold, air pressure in the intake manifold again, and a measure of the residual oxygen in the exhaust manifold, yeah? Engine RPM, camshaft position, crankshaft position, engine load, and engine coolant temperature. After the completion of thinking, the ECU need to do is the next step command. The injector is controlled by ECU, responsible for adjusting the fuel injection and fuel injection time, while the pump is responsible for supplying the fuel. Okay, let's go to the GT power. Actually, you can use signal and phasing as ECU. The symbol allows a time-based profile or a series of profiles to be phased or shifted to a start at desired angle. Common applications include an energizing signal for a solenoid valve or a detailed injector. Typically, energizing duration is known in time, but the profile should start at a known cam or crank angle. So let's click on that. What we have here, profile definition tab. Angle for a start of profile and profile reference object. Okay. Angle for a start of profile. The time-based profile specified in profile reference object will be shifted to a start at angle specified by this attribute. The shift is relative to the driver selected in the angle source folder. And profile reference object, yeah. Profile transient reference object defining the profile. If the profile transient has a period longer than the driver, values corresponding to a time longer than the cycle duration will be ignored. At the start of the next cycle, the lookup will begin from the start of the profile. Okay? If multiple profiles are specified and they overlap, their outputs will be added together to create the output signal. So we have multi-cylinder. This folder allows the base profile specified in profile definition to be duplicated and phased, typical for multi-cylinder applications. Firing order. This attribute is the firing order of signals. It is an integer value defining the order of the output signal when the outputs of the signal gen phasing component is linked to other parts on the model map. And you can see the phasing of the output signals is set in even firing order or firing interval depending on user selection. If wireless signal control is desired, please use receiver of wireless signal to define the order of the output signals. An even firing order. This option will phase the profile for each output signal by a constant value. And I want to show a constant value. Let me show you. You can see this is constant value and number of output signals defined, degree per cycle of driver, and greatest value defining attribute firing order. And we have firing interval. This option will phase the profile by an arbitrary angle set by the user. The profile will be phased relative to the start of the previously output profile. Okay, and a receiver of wireless signal. This attribute is optional. It is possible to wirelessly push the output signal to other components on the map if the outputs of this component is not linked to other parts. This attribute specifies the name of the signal in another component, which will receive the profile generated by this template. This allows the user to send the output signal to a part without any links on the model map. If direct links are used instead of the wireless feature, this attribute should be set to ignore. Okay, and we have angle source. Let's go through that. Here we have angle source, main driver, part on map, driver reference object, main driver. The angle of the main driver is specified in run setup, greater than time control, and main driver. This is the most common option. Part on map defines the specific part on the map that the template will use for the angle, and driver reference object define the driver reference object. Okay. Actually, each signal gen phasing object allows any number of output connection. The number of unique output signals will depend on the number of firing order columns specified in the multi-cylinder folder. Output signals may be transmitted wirelessly or through direct links. For direct links, the output can be connected to adjacent control components and or non-control parts via actuator connection. So let's go to the example. In this example, two profiles were specified in the profile definition folder. The angle for a start of profile was set to 0 and 20 degrees for profile 1 and 2, respectively. This signal for cylinder 1 is then duplicated and phased for other cylinders through the multi-cylinder folder. A sample multi-cylinder folder and its resulting output signal are shown in this slide. For a case below component outputs are directly linked to other parts. The firing order of 1, 3, 4, 2, we can see that is imposed by using the firing order attribute, and the firing interval is used to set an angle of 180 degrees between the start of one profile to the next. This is the same as selecting even firing order for a 720-degree driver, and is shown here as an example of how to specify firing intervals in engines with uneven firing intervals. Okay. The multi-cylinder folder shown in this slide will also give the output signals that are shown on the plot. But for this case, wireless signals are used to pass on the output signals to the receiving parts. When wireless signals are used, the order of the output signals is determined by the receiver of wireless signal attribute. And if the duration of the base profile specified in the profile definition of folder is greater than the duration of cycle defined by the angle source, values corresponding to time longer than the cycle duration will be ignored. At the start of the next cycle, the lookup will begin from the start of the profile. In behavior, if the profile overlap, if multiple profiles are specified and they overlap, their outputs will be added together to create the output signal as shown on the right side.